So moving to the next question again, we're working with quadratic equations. A quadratic equation takes on this look here, ax squared plus bx plus c is equal to 0. So there's going to be a power of 2 involved. So this is described as a second degree equation. So a second degree equation for us, what this tells us is it can have up to 2 possible solutions. Some other vocabulary, the quadratic term is the term that has the x squared in it. So the ax squared is called the quadratic term. The linear term is one that just has the x in it, so the bx is our linear term, and then the constant is just going to be a number. Now, when it comes to solving quadratic equations, one of the strategies is what we do is use what's called the multiplication property of 0. So if one of the factors is equal to 0, then the product is also 0. So what this means to us is if A represents a factor times B, which is another factor, this can only equal 0 if A is equal to 0 or B equals 0. So if either A or B is equal to 0, then the left side turns into 0. The product is 0. And remember, for an equation to be true, the left side has to equal the right side. So if I can make the left side turn into 0, then this is a true statement. And I can do that by making either the first factor 0 or the second factor 0. So this brings us to question number 4. I pick up on that it's a quadratic equation because of this power of 2, but notice how it's not set equal to 0. So remember, I need ax squared plus bx plus c is equal to 0. So what I can do is subtract 35x on both sides. So if I do that, what basically happens is this 35x will come over here, but when it comes over here, the sign's going to change. So I'm going to write this as 7x squared minus 35x is equal to 0. So we start to play this jump game. If I jump across the equal sign, the sign changes. And when I jump across, since there's nothing left over here, we use a 0 as a placeholder. So again, the strategy is factoring, because if I could change it to factoring, then we could use the multiplication property of 0. So if I look at this one, notice how there is a GCF involved here. So again, if I look at this as 2 terms, make that a little bit better. So if I look at this as 2 terms, the 7x squared and the negative 35x, what do these 2 terms have in common? Well, I can see an x in common, but is 7 also a factor of each one of these? I believe so. I think 7 times 5 is 35. So what I'm picking up on is 7 is a factor of both terms, and they both have an x in common. Notice how this has 2, this has 1, so the most in common would just be 1x. So then, to find the missing factors, what I can do is focus up here and ask myself, what times 7x gives me 7x squared? Well, if I took out a 7 and an x, that's got to leave me an x. So 7x and times an x does give me 7x squared. If I take the 7 and the x out, what factor is left? Well, that means I would have to have a negative 5 left, because negative 5 times 7x does give me my negative 35x, so that would be the remaining factor. So x minus 5 becomes one of the factors, and 7x becomes the other factor. So what I can do is factor out a 7x, and then in parentheses, I write the remaining factor, which is actually a binomial, x minus 5 is equal to 0. Now, one of the things you actually can do is get rid of the leading coefficient, the 7. I could have divided both sides by 7 to begin with. I didn't see it, but I can divide by 7 now, and I can make that 7 just go away. So that's just going to leave me x times then x minus 5 is equal to 0. So I actually can make the 7 go away as well by dividing both sides by 7. So now we're down to just these 2 factors. So what we can do is set each one of those factors equal to 0. We can set x equal to 0, or we can also set this x minus 5 equal to 0. And notice how that does equal 0 already. If I solve this for x, I'm going to get 5. So what we're picking up on is there's 2 solutions. 0 and 5 would both work in this problem. So notice how it says simplify your answer and then use a comma to separate your answer. So up here you would just be saying x equals 0, comma 5. So you'd have those 2 solutions, 0 and 5 would work out. So on this one here, we're seeing that they do have a common factor of a 7 and an x. So and again, we may see that a little bit differently, but that's kind of the sense of the problem. So see if we can kind of continue to develop some easier strategies as we move forward.